Hello, here's another AQA A-level physics question on simple harmonic motion. If you want to try to answer the question yourself, pause the video now. If you got the answer right, well done. So a simple pendulum and a mass spring system perform simple harmonic oscillations on Earth with the same time period t. Both systems are moved to a region where the gravitational field strength is 4 times that on the surface of the Earth. What is the period of each system when oscillating in this new location? So, equations are going to help us. Let's look at one I'm going to start with, and that is the time period for a spring mass system is equal to 2 pi multiplied by the square root of the mass over the spring constant. So, first of all, in this equation, there is no term for gravitational field strength, so the time period is not proportional to gravitational field strength. So wherever I take a spring mass system, the time period, wherever in the universe I take that spring mass system, the time period will be the same, whatever the gravitational field strength. So for the spring mass system, T will remain the same. Okay, what about for a pendulum? Well, again, from your data sheet, you're given the equation. The time period for a pendulum is 2 pi multiplied by the square root of the length of the pendulum over the gravitational field strength. So we can see the time period is affected by the gravitational field strength. I can forget the 2 pi and the L because we're not changing them in this case. So I can rewrite this and I can say that the time period is proportional to 1 over the square root of the gravitational field strength. Well, I'm going to increase the field strength by 4 times, and that means the time period will change by 1 over the square root of 4, which is a half. So the new time period will be the original time, half the original time period, or t over 2. So the answer is A. If that was useful, subscribe, share and like, and watch more of them in the series. Thank you for watching.